This is a second video on triple integrals. And so for this, we're going to look at example 231, where we're going to use Fubini's theorem to calculate a triple integral. And so our region R is simply this box, 0, 1, cross 1, 3, cross negative 1, 0. So this is our rectangular prism in 3 space. We're going to integrate over that prism this polynomial of 3 variables. And so we have this polynomial, we're going to integrate this. Now, what Fubini's theorem says is we can integrate this variable by variable. So we have the x interval, the y interval, and the z interval from the inside out. So we integrate with respect to x, then with respect to y, then with respect to z. Again, we go from the inside out. This is not terribly difficult, it's just a little bit tedious. And so this is very similar to what we do with the functions of 2 variables. It's just that we have an extra step because now we have a function of 3 variables. So we start by finding an antiderivative with respect to x. That means we treat y and z as constants, and we find an antiderivative with respect to x. So we have 1/3 x cubed times y plus 1/3 x cubed times z plus x times y times z. So here's our antiderivative down here. We'll substitute 1, we'll substitute 0, we'll subtract. When we do that, now all the x's are gone, and now we have an integral in terms of y and z. So we substituted 1, we substituted 0, we subtracted, and now we have this double integral. This is simply a problem from the previous sections. So now we have our y interval and our z interval, integrate with respect to y, then z. So we find an antiderivative with respect to y. We're going to pretend z is a constant and just find an antiderivative with respect to y. So we have 1/6 y squared, then we have 1/3 yz, then we have 1/2 y squared z. We'll substitute 3, we'll substitute 1, and we subtract. So that's what we do here. Substitute 3 for y, then we substitute 1 for y, then we subtract, then we simplify, and now we just have a linear function in terms of z. So the integral from negative 1 to 0 of 14/3 z plus 4/3 dz. This is a Calc 1 problem. So we find an antiderivative with respect to z, substitute 0, substitute negative 1, subtract. And when we do that, the answer is negative 1.